Record. All right, we're on number 10 on the video, on the review for the 3.1 to 3.5 test. Number 10 talks about a student experimenting by turning the key of a wind-up car and recording how far it goes. So the table shows us the number of turns of the crank and then how far the vehicle travels. So if you haven't done this already, go ahead in your calculator and put the data in list 1 and list 2. You can pause the video while you do that. Now that the data is in there, you can see that list 3 is just kind of waiting for us. And what list 3 is going to house, it's going to have the y hat values, those values from that median line that we talked about in section 3.5. So what I want you to do to find the median line is you want to go to stat and then over to calculate and do option 3, which will go ahead and calculate the median line for your data. Enter, and it gives you the slope and the y-intercept that models this line, the line that will fit the data. So the start value will be 1.46 repeating, and the slope will be 73.2. So what we want to do then is we want to go to y equals and put that equation in. And I already did that here, but you could do it now and hit pause. Now that you have the equation in y1, we can go ahead and tell list 3 to pull y values from here. Or, better yet, you can go over to list 3, so go to stat, edit, and at the very top of list 3, you can go ahead and type in the equation for the median line. So what was the slope? 72.8? Is that right? 73.2?
Yeah.
Okay, so we have 73.2 times x, but we don't want the x there. Instead of x, we want to tell it where to pull the x values from. And we want them to come from where, Liz? From list 1. That's where our x's are. These are the x values, so we're going to tell it to pull those from list 1. So second 1, we put in list 1, plus the y-intercept was 1.466 repeated. Okay, so put as many 6's in as you feel like, and then hit enter. And what will happen is list 3 will just self-populate with that data. So it'll go ahead and put in 0.5 and give you a y value. 1 and give you a y value. So those are the y's from our line of best fit. Now that we have those, we can go over to list 4 and find, what's that new term for this section? Good, residuals, which tells us how to find the difference between the actual data items in list 2 and the projected data items in list 3. Now, a very common mistake is to just go over to list 4 and type in L2 minus L3. You can't do it right here. Where do you have to actually type that formula? Up at the top. You go all the way to the top, and you're telling list 4 to be list 2. So here, list 2 minus list 3. List 3. Okay? And when you hit enter, it'll go in and subtract 33 minus 38.06. 73 minus 74.6, and so on. So let's go ahead and hit enter, and it calculates all those residuals. Go ahead and continue. So the next thing we need to do is to go over to list 5 and do what with the residuals, Elena? What do we do with them now? The root mean square error, we're at the square level, square. What do we got to do to them? Square them all. So let's go up to list 5. How do we tell list 5 to square list 4? Second? Everybody. 4 squared. So it's going to take all those numbers and square them for us. That's a big time saver. Otherwise, we'd have to go through and do them all by hand. or did them all one at a time on the calculator. So it does them all for you. Almost there. We quit out of here and finish the process. How does that work? Okay, second 0 takes us to the catalog. And this is a listing of everything the calculator can do.
And then you scroll down to sum,
Scroll down to sum by going down to the S's. Okay, and we want sum, right? We want to find the sum of what, Veronica?
of the square.
And what lists were those in? With the square?
Square.
They were in list 5. All right, so it's going to add all the numbers in list 5. Remember, a couple days ago, we were doing all this one step at a time and writing down every single little answer along the way. So this is a big time saver. That's the sum of the residual squared. Then what, Jackson? After you find that sum, you divide by
Oh, you got it by 6.
6. How many data items were there? 8. You always subtract 2 from it. All right, so we're going to divide by 6. And we're really close. It's the last step. Square root it, and we are there. Take the square root of your answer, and you are. Come on. I don't know what's going on.
Thank you.
Okay. And that is the root mean square error. That number tells us how far off any data item might be in that linear regression. 3.6 units.
Go ahead.